So algebra. Let's do some, first of all, math, and then within math, one of the four major sections is called algebra. Within algebra, here's one of the subtopics, linear equations in one variable. So please work through this PDF on your own. There are 10 questions. When you're done with that, come back and please resume watching. So hi, if you're still here, I'll assume you're ready to review your work. I have here not only the questions we're going to be dealing with, but also I've set up Desmos here. Let me just do that. I've set up the Desmos here. This is the calculator that comes with the PSAT, also with the SAT. So let's just get right into it. Let's say that you're looking at question 1, b minus 2 times x equals 8. And it says that b is a constant, and you're like, what is a constant? If the equation has no solution and you don't remember what that means, what is the value of b? And you're like, here's what you can do. Go directly to Desmos and type in exactly what it says, b minus 2, x equals 8. Make sure it looks right. Now, notice the triangle of sadness there. That means it's not going to play that game with you. But here's the cool thing. It says, what is the value of b? And it's giving you 4 different values here, right? So what if we just try out a value? So instead of b minus 2x is 8, let's just put 2. Notice that you don't see anything on the graph yet at all. Don't be mystified. Just let's try out answer choice B, which is 4. Oh, look at that. Now there's a line going up and down, crossing the x-axis. That means there's a solution. Okay, so with B, there is a solution. How about with answer choice C? Oh, look, there's also a solution. How about with answer choice D? Boom, boom. Oh, look, there's a solution. So D and C and B are all giving, hey, there's a solution. Only answer choice A is like, no, there's no solution. So there you go. Pick it. Okay. Mathematically, the reason, of course, would be 2 minus 2 is 0. And so we would end up with 0 times x equals 8. 0 times x would be 0, and 0 equals 8. That's, yeah. So here's the mathematical reason. But for your purposes, just use Desmos. Why bother to think when you can use the calculator? Okay, excellent. Let's see this one. If ugly equation equals another ugly equation, that's mysterious. The value of x plus 6 is between, oh my goodness, okay. Good times. Yes, of course, you could probably, not probably, you can cross multiply and figure things out and blah, blah, blah. But again, why not just let the robots do it for you? Let's just see how that might play out here. So if you do x plus 6, now watch this. If I go like this, that's not what we want, right? So what you'll want to do is put this in parentheses. So we've got our x plus 6, and we're going to divide all that by 3. Now notice if I immediately do an equals, that's weird. So just move over 1, then do the equals. So let's finish that thought. Cool. Now take a look at this. What I mean by this is there's obviously a blue line going up and down. Whenever you get the line going up and down, that's kind of Desmos' way of telling you, woohoo, here's the solution, yay. Okay, so the solution would be at -6, 0. If you want, you can also click on that and move it over here. You can label it, all kinds of cool things you can do. Basically, they're asking us, what's the deal with the number -6? Is -6 somewhere between -7 and 3? Well, yes, it is. Is -6 between these two numbers? No. Is -6 between? No. Is -6 between? No. Here you go. What's faster? Cross multiplying, figuring out what x is, then doing x plus 6 and then tet, or this? Of course, this is so much faster, right? Beautiful. I feel like, why not? There's a couple of things you can do here, actually. Obviously, you can Desmos this. I will in just a moment. But, some of you might look at this and say, well, hold on. They both have an x minus 5 going on. And if you've got 2 of them plus 3 of them, I think that's the same as 5 times x minus 5 is equal to 10. And they want to know what x minus 5 is, right? I mean, well, what if we just go like that? Again, Whatever for you is the fastest way to go is the correct way to go. So if that didn't occur to you, you could do it all on paper or whatever, but I would rather probably just do this. What is it now? Plus three. Yay. And then you click on here, and there's your answer. Not your answer. Remember that this is, of course, the solution. What is the solution? The solution means, the X value. And notice the trap answer. See, this is kind of fun. Respect this trap answer. The way to fix this, and part of what I'm wanting you to get here, is this idea that you should always, when you do your calculations, either on paper or with Desmos, always make sure that you read the final question. What is x minus 5? So instead of x minus 5, you put your 7, and then you put your minus, and then you put your 5. I mean, if you know that 7 minus 5 is 2, you don't have to do that on Desmos either. But why not? Why not? So either way, it's 2. So again, make sure always that you read the final question before you pick an answer. Okay. The temptation is there. I mean, you even heard me say it. I'm going to go, there's your answer, 7. I'm like, wait, that's not the answer. It's the answer to a different question. Like, what is x? X is 7. But what is x minus 5? 7 minus 5. You get it. Moving on. Good. Again, notice the x plus 4. So they're saying that 5, here we go, x plus 4 equals 4, x plus 4 plus 29. If you see it, well, there's a couple ways to see it. What I mean by this, seeing it. What if we subtract 4x plus 4 from both sides? Well, then we get just 1 times x plus 4, right? And then these two cancel out, and then we get 29, right? And I have students who will then go on to be like, and therefore x is 25, and therefore it's b. Lol. If you RTFQ, you know that you just need to find what is x plus 4, and you're like, I think it's 29. You can also do this on Desmos. I'll spare you. You know how to do it. Just type it in, find the x value, which of course is b, and then read the freaking question. Read the final question. RTFQ, read the final question. Okay, excellent. All right, moving on. 2 ways to do this. Let's do the Desmos way first. Why not? Okay, so we have 4x minus 1/2. That's exciting. Move the, space over 1 before you hit equals. Boom. -5. Yay. Okay, good. So what's the deal here? Boom. Here's our answer, right? What an ugly answer. That's gross. What do they want to know? RTFQ. They want to know what 8x minus 1 is. So we're going to put 8x negative 1.125 minus 1. Yay! It's apparently -10, and we're done here. Thanks, Desmos. Appreciate it. Thanks so much. Cool. Do y'all want to see the non-Desmos way to do this? Again, it's like, if you see it, this might be faster. If you notice that, okay, here's the initial equation, and if you kind of RTFQ and you realize that, well, if they ask you something like what is x, probably just Desmos. If they ask you something weird like this, it can be helpful to just realize that if you take this entire equation and multiply it by 2, I mean 2 times 4x gives you 8x. 1/2 times 2 gives you 1. And they want to know what 8x minus 1 is. I'm pretty sure it's 2 times -5, right? Again, 2 times the 4 gives you the 8. 2 times the -1/2 gives you the -1. And 2 times -5 gives you -10. So if you see it, that might be fast. If you don't, Desmos is very fast too. Great. Love it. Yes. This is particularly one that I have a number of students who are like, I know how this works, how many solutions, because therefore, and this, and if I calculate it all out, and what I have found, it's safer to do the following. Now, I'm going to do this. Let's do this. So I can't type and talk at the same time. I want to do something slightly different. I'm not going to put this on one line. I'm going to do that. And now we have one line called 10 times 15x minus 9. Yay. And now I'm going to do another one called negative 15. Boom. 6 minus, what is this, 10x? Yes. And I'm going to look. And I'm going to see, okay, I have a line going up and down. Hey, where'd the red thing go? If you click anywhere in here, you'll see the red line. See the blue line. See the red line. See the blue line. See the red line. Zoom in if you're not sure what you're seeing. It's like, wait a minute. Are my eyes deceiving me here? Is this really what's going on here? Yes, it is. Do you all agree these are the same line? And because they are the same line, they do not have exactly one solution. We're not, sometimes people fall for this because they think, oh, it goes through the x-axis, once. No, 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 no. We're saying how many times are these two lines equal to each other? It's definitely more than two, and it's not zero. It's infinitely many. I'm going to leave it there for now. We could talk about slope and everything, but we'll get there momentarily, okay? Or perhaps in the next video. Let me see here. Yeah, maybe with this one, we'll do it with 8. Okay. What I'm trying to get at here, I don't want to like hide information from you. When you have infinitely many solutions, I mean, the lines are the same, which means they're going to have the same slope and the same intercept. Anyhow. Okay, moving on. Number 7 does not, well, let's just read it first. Okay, the width of a rectangular dance floor is W feet. My advice regarding word problems is, as soon as you have something that you can draw or calculate, do it. Don't read everything. The width of a rectangular, so let's draw a rectangle. The width is W. So what do we have here? Length times width. Why don't we put W here? Because that's classically where you put the width anyway. Next sentence, the length is 6 feet longer. Okay, well, that's pretty cool because I drew it that way. Instead of writing L, what do you think we should write? I mean, if the length is 6 feet longer, 6 feet longer, why don't we do that? Yay! In some versions of this question, they would ask you, what's the area? In some versions of this question, like this one, they ask you, what is the perimeter? Oh, well, the perimeter just means you add up all the sides, right? So there's one W, that means there's another W, so there's two W, the two widths. And then there's, W plus 6, and then another W plus 6. You can call it 2W plus 12 if you like, whatever. So ultimately, that gives you a 4W plus 12, and there's your answer. That's the perimeter. Notice that if you don't really read, if you don't read the final question properly and you start calculating the area, you're very quickly going to get W times W plus 6. So the area would be W squared plus 6W. Oh, that's the area. What a nice trap answer. Got to respect the trap answer, right? Notice we didn't need Desmos for this. This is just a kind of a word problem, just, some geometry. Just do it. All right, moving on. This one's fun. What's the value of A if, the equation has infinitely many solutions? There is, of course, a pretty easy way to do this on paper, but let's just say that you're not feeling it. Okay. All right. So here's one line. Where is it? By the way, notice I zoomed in quite a bit, and I'm like, hey, where's my line? You can always zoom in or out using these two buttons. And to recenter everything to just quote unquote normal view, you can always click on the little house. Thank you. So here's this. Yay. So yeah, let's put the other one. So what is it? A x plus 8? Yeah, x plus 8. Now look what's happening. This is a good thing. This is not the triangle. Well, it is the triangle of sadness, but there's a solution. The triangle is sad, but it's telling you, hey, too many variables. Try defining A. Try. Okay. How encouraging of you. Anyway, so whenever you're prompted to add the slider, please do it. Always add a slider. Okay. Both at the restaurant and Desmos. Add that slider, please. Okay, right now, if you look at the green and you look at the purple, how many solutions does it look like this equation has? I mean, they touch once, so there's one solution. They could ask you about having 0, or they could ask you about having infinitely many solutions. So for infinitely many, what's the value of A? Well, let's just start dragging A around. If I start dragging in this direction, it's not really doing what I want. Whoa, if I start dragging it in this direction, And I am getting closer and closer here. Let's do this. Maybe I can, come on, you. Got to play with it a little bit. But I think, if I zoom in a little bit and I look, or if I zoom out, it's another good way to do it. I mean, here's the green, here's the purple. They clearly are the same line now. So apparently A has to be 2. Okay. The value of A is 2. If you don't prefer Desmos, that's okay. Let's just do AX plus 8A. So infinitely many means they're literally the same, which kind of low-key easily tells you, I'm pretty sure that A has to be 2, because if A is 2, then 8 times 2 is also 16. And so again, whatever for you is easiest. Paper, Desmos, doesn't matter. 9 looks annoying. And by the way, yeah, if you were, not that we have all the time in the world here right now, but imagine you're taking a test and you're stressed out and you're like, you only have a few minutes left. You might skip 9 initially and go do 10, Let's see what happens here. Well, actually, so looking at 10, okay, yeah, K is a constant, great, fine. If the equation has infinitely many, and by now you know that means that they're literally the same equation, and you're like, well, these are already literally the same, so I am pretty sure that K has to be 5. So aren't you glad you did that one before, stressing out over 9? Imagine working on 9 and running out of time and not getting to 10. That would be painful, right? Just for fun, though, I wanted to run this by you. 6x plus k, yes, 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 give me the slider, fine, great, beautiful. Now 6x plus 5, 6x plus 5, good. Okay, so right now, what does this look like? Interesting. Right now, it looks like they have no solutions. And sometimes you'll get that question. If that were the question, if it said no solutions, then the answer would be k equals 1. But in this case, if you start dragging around, ooh, look at that, look at that. It's going further and further away. It's getting closer, it's closer, 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 closer. Oh, it's going further away. Come back, come back, come back. Be with me, be mine. And now they are together forever and ever, two part. Okay, good. Anyway, k equals 5. Do, 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 do. All right. Let's see here. Last one. All right. Megan's regular wage at her job is P dollars per hour for the first 8 hours of work in a day. Oh, okay, interesting. So it looks like it's $8 per hour, $8 per hour. And that's just for the first 8 hours, right? First 8 hours. Where is she working? Okay, anyway, plus 1.5 times her regular hourly wage for work in excess of 8 hours of that day. So let's just call this overtime. 1.5 times her regular hourly wage. What is 1.5 times her regular wage? I mean, you could probably do this in your head, or since you're here, you could say, well, I think it's 1.5, and I think that times means maybe this, maybe, and her regular wage is, I think, 8, and so I think it's $12 an hour now, right? So notice how Desmos can sort of help you out. So for the first 8 hours, she makes this, and then after that, she starts making that. That's exciting. So on a given day, she worked for 10 hours. Um, yeah, okay. I need more caffeine. Notice what just happened to me. And this may happen to you. How many of you caught the error? This could happen to you. So it's okay. Just be able to catch yourself. It says P dollars per hour, right? Her regular wage is P dollars per hour for the first 8 hours, plus 1.5 times that, 1.5 times P. Ooh. Okay, great. So on a given day, she worked for 10 hours, which means, she worked her 8 hours and then she did 2 hours of overtime, right? And it gives us her total. So what is the regular hourly wage? There are a few ways you could do this. One way I would recommend, let me erase this for just a moment here. One way I would recommend is noticing that the answer choices are actual numbers, right? So what I mean by that is if you on your paper just say, okay, well, her regular hourly wage is, my recommendation also, if you're going to plug in the answers, is to start with either of the two middle values. I actually don't know the answer to this looking at it. I'm seeing this for the first time. So I'm just going to pick B because it's a nice round number. If her regular hourly wage is $12.50, okay, and she worked for 8 hours, first 8 hours, how much money is that? Well, that's 8 times 12.50, right? So she just made $100. So let's do that. She just made $100. Good job. And then we've got she worked 2 more hours. This is the overtime thing, right? Hours. I can spell, I promise. So she works 2 more hours. And we said that what is it? That's going to be 1.5 times her regular hourly wage. So 1.5 times her regular hourly wage, right? Which would be like is that right? Yeah, good. That would be, that would be that much per hour, 18.75 an hour. It's exciting. So that's per hour, and we know that she did 2 hours of that, right? So that means she just made 37.5, meaning 37.50. Sounds good. So then the question is, if she works this and she works, I'm going to expand this now. If she works, I'm going to try. Come here, you. There we go. That's better. So if she works the 8 plus the 2, that's going to be the 10 hours that she worked, right? The 100 plus the 37.50 is 137.50. And does that fit the question? Yes, it does. We're done. Yay. Thanks. If we had gotten a number that's too small, we would go down to C and D. If we got a number too big, it would be A. So I guess the trick here is, the strategy here is going to be called plugging in the answers. I'm going to PITA, okay? PITA. Good with hummus, right? Plug in the answers. Just set up a column, pick one of the middle two numbers, try it out, and then you don't have to get lost in all of the algebra. So quick review of everything, briefly. For many, many, many questions, you either can see it on paper quickly, do it on paper in that case, or you can do it very quickly on Desmos. Powerful tool. So paper and Desmos worked for 1 and 2. Either way worked for 3. Just make sure you always read the final question. Okay, so paper, read the final question. Sorry, paper, Desmos, read the final question. Paper, Desmos, read the final question. Paper, Desmos, read the final question. Yay. In this case, also, for geometry stuff, draw things out. And for word problems, read like one phrase at a time, write something down. One phrase, write down. One phrase, write down. Watch out for traps. They don't want the area, they want the perimeter. Paper or Desmos, up to you. For 10, paper or Desmos, up to you. And for number 9, notice how number 9 initially led me astray for a second and a half. Just be willing to catch yourself when that happens. Happens to us all. For something like this, if the answer choices are actual numbers, then rather than do algebra, once I got started doing the algebra, I was like, this is gross. When you see that the answers are numbers, you can always just plug in the answers. Okay, great. Please go forth and try more of these linear equations in one variable. These all came from the medium territory. So if you go to the website, you could try out some of the easy ones, try out more of the medium ones, try out some of the hard ones. If you need further assistance, we have SAT classes coming soon. I'm sure that you'll have a date starting soon. Just take a look on the website, and there's individual tutoring available. You know where to find me. Hit me up. Be well, everyone.